Alright, time for another DraftPhysics.com, debatephysics.com, but the debate so far can't find anybody who'll just answer simple questions. So I'd say if you're going to make some sort of snarky or stupid comment, first you ought to just answer the simple question. You know, does it take 100 times the energy to spin a motor 10 times as fast? Or 25 times to spin it 5 times as fast? Answer the question. Do you really think so? And if your answer is no, then you have a problem. Okay, you can't really defend the physics that says that really has to be true. Frankly, their physics says so. All right. Unless you have some other alternative explanation, like somehow it doesn't say so, that somehow the math doesn't say so. I'd like to hear it. All right. So anyway, I did. I was looking at the Professor Lewin experiment again, and I did notice something, so I figured it was worth playing it. So I will blow this image up, and then we'll play the little clip. And there's something you see that just, indicates more reason to doubt. And so we'll play this second clip in the same lecture, where the experiment comes out completely different. Basically the same experiment. Alright, this should be close enough. So just watch this hand over here, the hand on the heavy cart. So he does hold the carts to keep them from moving before they collide. And that's sort of reasonable because they will move. Unfortunately, that's the liability of the air track, is that it can create phantom velocities. Alright, but anyway, regardless of that flaw, there's a kind of glaring, so we'll play a little.
You see this one come in, gives you the time here. This one goes through here, gives you the time here. This one will come back, gives you the time here.
So you will see the clay on the little cart, and it has the extra 2 weights. The other one doesn't have 4 weights. Lots of reason to think these carts aren't what they say they are in terms of the weights. And what's sort of just sticks out, that if, let's say, this little cart is substantially heavier, like maybe even the same weight, then you'd expect it to just transfer all of the energy, and it doesn't do that. And I would argue the reason why it's not doing that is because he actually is holding it until it hits, and then he lets it go. So that's what I'll say is I've observed.
ID 0.
Okay, so you can see the nice little clump of clay here, how much clay it takes to add up to how much aluminum is on this, the extra aluminum on this other cart. That's essentially the argument, that the extra aluminum is being compensated by the extra clay and the absence of the 2 extra weights that should be on this cart.
Okay.
So somewhere in here I'm going to try to do this in slow motion.
You ready?
So watch this hand. Okay, this hand is actually holding the cart. You can see it doesn't go, it doesn't go down to some button down here. It's just staying right here. He's got his finger on the cart, and his other fingers are dangling down here. So that's what you need to watch, and how long it takes that to get out of the way. So hopefully I can do this without screwing it up. So here we go.
Go. Oh.
Any minute now. So his hand is still there, holding the cart. So you would think you would let go. When you let go of the one cart, you'd think you'd probably let go of the other one, because it ain't going to move much in that little tiny bit of time. But his hand is still there. Still there. Whoops. So you saw that it didn't really leave until after they hit. And if you do this, if you do this very well, that's what you see, is that his hand doesn't leave until after they've hit. So maybe we can try again. See, they're going to hit right there. So you're not going to, but you can see his hand is still there. The springs are actually touching now. The springs stick out quite a bit. So they're actually in contact right now, and his hand is still there. There. You can see the cart's moving, and his hand then leaves. So he's forcing the reflection. The reflection, look how he's concentrating on it, right? I mean, it's not that complicated an experiment, right? You just push the cart is all he really has to do. And he's really concentrating on what he's doing here. So just pointing it out, okay, it don't look good. That's just another piece of this experiment that just doesn't look. Look, his finger is still there. It hasn't left yet. The cart's moving. And right there you see it move, twitch a little, and now it leaves. So just pointing it out. All right, so let's go to the other clip. All right, so this is where he does the experiment, and they're supposed to stick to each other, and they don't. So it duplicates the other experiment, one mass into a two mass that ends up being elastic instead of inelastic.
Which is twice the mass. And this is once the mass. I will set them again to 0. And now we get 1 onto double the mass.
So, and the momentum is perfectly conserved. Let's understand. So the momentum's perfectly conserved, so there's no excuses that a bunch of energy was lost somewhere because the momentum is conserved. So, you can't really use the excuse that, well, they didn't stick, but they partially stuck, and they did that. No, it doesn't really fit because the momentum is still all there.
You ready?
And in the same direction, by the way. The momentum's all in the same direction. All right, so watch his hand this time. So his hand is still holding it, okay? You can see his little finger down here. All right, there's his little fingers. So his finger is on the cart.
Yep. We go.
Okay, I can't remember if they show me or not. Let's see. My bad. So his hand is out of the picture, okay? So he moves his hand a lot sooner in this case than he moved it in the other case. All right, one's the mass, two's the mass. Okay, let's try again.
We go.
All right. So the hand is still there. And you'll see the other cart come into the pit. Oh, see, it's a little tricky. Sorry. Try one more time.
Which is twice the mass.
Yes, we heard that part.
This is once the mass.
Yes.
I will set them again to 0. And now we get 1 onto double the mass. You ready?
Yes, but I'm going to screw it up again probably. Here we go.
We go.
There we see the cart. Okay, so the cart has entered my picture. Now his hand is changed. And one more. One more. There. You can see his hand gets off the cart before the two contact each other. So clear difference. All right. So just saying, it's just more stuff to say this experiment is not at all done right. And you can see here, okay, you can see both these carts, right? Yeah. No weights on the lighter cart. Just a clear bar there. No, this weight is missing. So understand, on the other experiment, there's a big heavy weight on this cart, and there's probably one on both sides. All right. Now, why is there no weights on this half the mass cart, and there is a weight on the half the mass cart in the other experiment? And on top of there being a weight, there's a blob of clay on it also. So you have to ask yourself the question, why is the weight on this cart and there's no weight on this cart? I mean, if you're an honest person, you have to say, okay, yeah, that doesn't seem quite right. That doesn't make much sense. How come you need the weight on the small cart in the other experiment, but you don't need the weight on the cart in this experiment? How can the masses be what he's claiming them to be if he could put the two weights on here and it's still going to be half the mass. It just doesn't make any sense. All right, and until, I'm not going to let any of you liars say anything in the comments section until you account for this. You can't just sit there and keep pretending there's no counter argument. Here's your counter argument. Explain it. Explain how this is possible. Okay, that there's a weight on this cart and there's no weight on this cart. And then I can go back to the other experiment and I just say, how could the two be consistent? Because clearly in the other experiment, there's no such weights. All right, so let's go to the 2 mass to the 2 mass. So if we're here, there, whoops, I had it and I lost it. All right, let me pause. All right, I think this is about the best image I can show. So clearly weight on the 2 cart. There would be a weight on both sides to keep the carts balanced. Weight on the small cart, another weight on the other side, plus the blob of clay. So clearly these carts are these are 2-to-1 carts, and yet this cart has an awful lot of extra weight on it. It's just undeniable. It's an awful lot of extra weight. All right. Well, I mean, I'm sure you'll try to deny it, but I'm just saying it's just pretty clear. What the hell does it keep doing that for? I say move this thing and it moves something else. So you can see there it is again. Weight. No weight on the other. Half the mass cart, no weight in the other experiment. Okay. Pretty obvious. All right, back. So I guess we'll do some of these, some fool online's bullshit comments, and again, he won't answer my questions, and he keeps making statements that just aren't true, and so I'm just going to delete your comments until you start making one that isn't a lie premised on lies. Anyway, this has been explained to you before. Well, then cite a reference, link me to your explanation. All right, but meters per second squared is not a function. It's explicitly a function. You're squaring the seconds. That's a function. You're dividing the seconds into the meters. That's a function. There's no denying it's a function. Okay, it's completely not what Newton wrote. So let's just say this. Until you prove this is Newton's formula, then call it what it is, Leibnizian mechanics, and say that you're a Leibnizian. So premise it with these actual factual statements, or don't make statements, frankly. All right, it's not squared acceleration. It's clearly squared seconds. Okay, so whatever it is you're squaring a ratio. Newton's formula is 9.8 per 1 second. 9.8 meters per 1 second. Not seconds, and not seconds squared. That's the absolute fact. Until you refute that fact, all of this is just lying. Okay, it's just a unit. That doesn't even make any sense. A squared second is a unit. It's not possible to have a unit that's a squared second. It's not a squarable mechanism. There's no such thing as a geometrically coherent squared second. You don't replace those symbols with any numbers. So of course you do. So that's just, what do you think it exists for? Why do they say meters per second squared? 9.8 meters per second squared. Why do they say it? It's not a unit. It's not a real thing. It's not an actual amount. It's nothing. The numbers come before the unit. So exactly. So if I put a number in front of that square, I put a number of seconds in front of that square, you're going to square the number of seconds. And that's absolute bullshit. Okay, and the experiment is not magically transferred, and the exponent is not magically transferred into the kinetic. Yes, it is. So again, that's just an overt lie. The whole point of saying it is to put the square, to give you a squared unit, to give you a squared function. It's not there for any other purpose. Per second nonsense. I'm going 60 miles an hour per hour. You're saying it that way on purpose. Okay, you get the squared velocity by understanding that it takes twice the time to stop something. It doesn't, so this is just more bullshit. Going twice as fast when using the same movement resisting the effort. Well, that's obviously true. So how the hell does that have anything to do with squared? You get the squared velocity by understanding it takes twice the time to stop something going twice as fast. You're saying it takes 4 times the time. So again, just keep lying some more, okay, when using the same movement resisting effort. So, yeah, so again, what are you saying? That completely is in exact opposition to what you're saying. You're saying it takes 4 times the energy to stop it. If you want to make it stop faster, you have to push harder. So again, this is more nonsense. Actually, you get the squared velocity by just understanding how objects behave when they are being pushed. I don't see how I understand it at all. There's no explanation. There's no example. Show me a fucking physical example of this nonsense. A change in your velocity is not mean that you square something. It's just a change in your velocity. If your velocity isn't squared, why would your acceleration be squared? Acceleration is just a unit of velocity. You're either taking it away or you're adding it. There's no reason to square anything. And we know this pretty well. You don't know shit. Okay, that's why physicists are not publishing experimental evidence of kinetic energy. That's why physicists are not publishing experimental evidence of kinetic energy. Does that sentence make any sense to anybody? They have a reason not to publish evidence, and experimental evidence more specifically. That doesn't make any sense. What do you mean? That's why they're not doing it. There's absolutely no reason for a scientist not to publish evidence. Okay, that would be like publishing a new study, velocities of objects falling in gravity with no atmosphere. This can't make sense to anybody. Who could this possibly make sense to? It's clearly a distinction. If there's no atmosphere, it makes it even more obvious that your bullshit is bullshit. Nobody would care, so it would not get published. So again, that doesn't make any sense. Of course it would get published if it was saying something that's accurate. So that's more nonsense. I do indeed believe in free momentum as it is defined by you. So there, we're almost done right there. We really don't have anything to discuss then, do we? Because you don't think momentum does work. And of course, I'm going to say momentum, of course, does work. So you're just basically saying you believe in free work. So I'd say, fuck you. It's just, we have nothing to discuss. I believe in it because it can be explained rationally. Not to me, it can't. Okay, none of this gibberish is a rational explanation. I want to see a rational experiment. Small steel objects hit big steel objects. Okay, the small object comes to a stop and gives its momentum to the big object. Where did you see that happen? Okay, at the same time, both objects get compressed a tiny bit, storing kinetic energy. Says you. Okay, there's no evidence that steel compresses in the first place. And I would argue that it reflects. Okay, it doesn't allow for compressions and expansions. It just reflects energy. Then there is a bounce, the release of the kinetic energy, which gives equal amounts of momentum to the objects in the opposite directions. So again, so you said it stops, but it doesn't stop. So I say it just reflects. It goes into the steel, the compression wave, if you want to call it that, the energy passes right through. And if it can't move the object, it reflects. The electrons fly out and then they fly back in again because the object doesn't go with the electrons. The electrons move. If the rest of the protons don't go with them, then it bounces back. It just stays where it is. If you understand this, all collision experiments start to make sense. It's just absolute nonsense. Draw a picture, show me a picture. None of this bullshit you're saying has anything to do with reality. And you can't capitalize on momentum. Sorry. So it says you. There's no evidence that momentum isn't real and that it happens in every car crash. Every bit of momentum has to be explained where it went. Every time you throw a bowling ball into pins, you have to explain how the momentum was transferred. And you believe in nonsense, free momentum. You might say it's momentum that is stored in the spring-like compression of the objects. Well, of course, I'm saying momentum is the only possible kind of energy. Momentum is force, as Newton stated. Do you disagree that Newton said, basically, without playing semantics games, that force is momentum? You can exchange the two. But that does not make sense. You can't store momentum in springs, says you. If one object loses momentum when pushing the spring, the other object will gain it by pushing, by being pushed by the spring. Yeah, and the whole point is the spring is creating a time lapse between that happening. The spring doesn't function instantaneously. The spring just makes the duration of the momentum transfer longer. Exactly. It does not mess anything up. Well, as I just stated, so where you're saying that the spring doesn't store momentum when you just said spring just makes the duration of momentum transfer longer. So obviously it's just a transfer of momentum. This is the fact that you can shove it anywhere you like. This is a fact you can shove it anywhere you like. Isn't it fun to disagree? Whatever that could even mean. So again, what fact are you disputing? You just conceded my point. The momentum is what's transferred by the spring. And the fact that you are asking for evidence that kinetic energy moves spacecrafts is solid evidence that you still don't understand kinetic energy. Yes, I'm saying that, look, if it can't do the most elemental thing, which is cause matter to move, then it's not energy. Okay, the definition of energy is something that has the capacity to do work. The definition of work is moving matter. If you can't do that, then it's not energy. It has to move electrons, it has to move something. If it can't move them, it's not energy. So anyway, fuck you. This garbage. I mean, really, cite references that counter-argue what's in the video, okay? The video had the gun example, it had the rolling ball example. Did you counter any of that? No, you didn't. All right. So let's go to this piece of shit. Okay, remember the time when physicist Michael got different amounts of momentum from the spring depending on the weights? Exactly what I've referenced as a complete contradiction to the gun example. So I might as well draw this part. I mean, they're in complete contradiction. It's a complete paradox. It can't be called anything else. It's an unacceptable contradiction in the evidence. And it has to be resolved one way or the other. Okay, there's no explanation that's going to make both circumstances make any sense at all. All right, so you have this simple example. Now I should force you to answer the question. What do you think happens? Okay, what do you think? Which one of these experiments is accurately showing us how much energy? Okay, the explosion has. All right, so I take bullets of vastly different mass. So these have a 1 mass and these have a 1,000 mass. Okay, so 1,000 times heavier bullets. All right, same exact explosion, same exact explosion. The light things fly out with incredible velocity, okay, and they end up with 2,000 joules of energy going in both directions. 2,000. So I have a total of 4,000 joules of energy, wattage. 4,000 watts is what it says this explosion produced. In this case, I end up with 2 joules and 2 joules for a grand total of 4 watts of energy. So 4 watts here, 4,000 watts here. Same exact explosion. Which test is telling us what the explosive really has? So nonsensical right on its face. Now momentum says everything's just fine because these have exactly the same momentum as this. The momentums are equal. It all makes rational sense. Kinetic energy makes a mess out of it. Okay, and then we do the physicist Michael experiment. We have exactly the opposite result from a spring. So the spring is just some compressed force, or however you want to describe it. We're going to do the same experiment. We're going to put a heavy thing, and then we're going to put a lighter thing on the spring. And in this case, let's see which way. I guess this will be the light thing up here, a 1, and then we'll say this is a 2 masses. And somehow the light things are going to, be completely inhibited in collecting energy. And so there, let's just say the number is 200 is going to come out. Okay, 100 this way, 100 that way, and I'm going to get 200 out this way. So I'm going to get a total of 400 here. Same spring, same compression, and I'm getting more energy because I put heavier things in. I put heavier things in here, I get less energy. I put heavier things in here, I get more energy. So obviously that doesn't make any sense. Okay. And I'll make the simple argument this experiment was a piece of shit, frankly. It's a shitty spring he used. It's a shitty experiment. It's crap. Okay. But, you know, these are real dualities. You want to pretend they don't exist. Again, just absolute bullshit. And you keep defending absolute nonsense, okay? I mean, I started the video with the Lewin example. I mean, there's no way to explain away those defects in the experiment. Just no way to do it and be a fair cop. All right, the energy was still the same. So he's saying the kinetic energy was the same, yes, but the momentums were not anywhere close to the same. All right. The energy was still the same. Here you are not arguing against anything a physicist would say. Well, that's the whole point. We don't have any physicists saying anything, do we? They won't answer the questions. They won't explain the duality. They won't explain how this functions, how this is a rational circumstance, that the same explosion produces 4 watts or the same explosion produces 4,000 watts. Okay, where's their explanation of that? Where do they explain where the energy goes in the simple experiment with the 5-ton train? Where have they explained to us what happens when it has a tug of war? The 5-ton train against the 10-ton train going 5, right? Half the speed. Where do they tell us, predict? Where do they say anything? Show me one example of them explaining what happens in that circumstance. I mean, when I'm supposed to have twice the energy, will I get twice the result? No. What we have had physicists, Michael, admit is that, yeah, this, squared physics doesn't work in space. It doesn't move matter. That when you navigate a spaceship, it's just about the momentum. The kinetic energy is irrelevant. You can't make more thrust by shooting small things faster. It's just about the momentum. So again, just bullshit. Alright, I don't think there's any point in... I mean, there was some little ragged comment on the website, so I guess I might as well just see if there's anything new. No. So he says, some fool... Alright, this is the video. Okay, free momentum. Lost of excuse... making for why you won't respond to Dispar Labs video. So I responded to it. I mean, I explained, and then I showed the alternative experiment that came out exactly the opposite. So I think that's a pretty decisive explanation, is to say, look, when he's not forcing the experiment to come out his way, well, how does it come out? Oh, it comes out my way. Oh, that's right, it comes out the correct way. Oh, I think that's a counter-argument, fucker. So, fuck you. Mush. That's all there is. It's mush. Alright, so I think that's probably enough of a video, frankly. I don't know if there's anything else I need to go over in this video. Half hour's about right anyway. Well, I'll see. Yeah, we'll probably call that a video. Alright, so yeah, nothing back from either the people. The physicists, okay, the newer ones, and any willingness to answer any questions or interact in any way, which is, again, it's just unfortunate. But I will compile all of that stuff and see what happens. But yeah, it's disappointing how dishonest everyone is. It's just human beings are just such garbage. I mean, just, but 98% garbage.